Alright everyone, welcome to Lab 6, Part 1. So for Part 1 of the lab, we're going to be measuring the losses. So we're going to measure friction losses and minor losses. And so Carmela, if you would show the pipes around the top of the room. Ooh. All the copper pipes are what we're going to be working with today. And then on the board we have a diagram of where we're going to be taking measurements. So we're going to be taking pressure measurements at 8 different locations, shown here, and all around this square of the room. And the E are the elbow pressure gauges, the T's are the T pressure gauges, and then D is the downstream pressure gauge, and U is the upstream pressure gauge. So we're going to be using those, plus the manometers. So we have a glycerin manometer and a mercury manometer on different sides. So we're going to be taking the deflection readings from those as well. And we're going to do this trial 5 different times. And, is that right? We're going to do this 11 different times. And we're going to start it. We're going to put the pumps up to 50% power, and then we're going to open all the valves, and then we're going to bring the pump up to 90% power, and then we're going to take all of these readings, and then for each trial we're going to decrease the pump capacity by 3% each time, and then take the readings for each trial and do that 11 times. So we just turned the pump on and we turned it up to 50% capacity. Now we're going to go turn the valve under the downstream pressure gauge open 4 times, and then we're going to bring this up to 90%. So this is the valve that needs to be turned. So we take the safety foam off and open it 4 rotations. So so that's 1. You can hear the water start to flow. 1, 2, wow, 3, 4. I think that's about 4. Yes. All right. Now we're going to turn the pump up to 90% capacity. We just do that by hitting the plus arrow here. And you can hear everything in the lab starting to get louder. Cool. All right. Do you want me to cut? Yes. So for trial 1, we have the pump running at 90% capacity. We're going to take the readings of the manometers, the pressure gauges, and we're going to take the velocity here. We can start recording for each trial once the velocity is stabilized, and we can see here that the velocity is about stable. So for trial 1, we're going to call the velocity 14.10 feet per second. Now we're going to walk over to the upstream the upstream pressure gauge. And we're going to read this value. Upstream, we're going to call that about 40 psi for the upstream pressure gauge. Then we're going to go to the first T pressure gauge. The first T pressure gauge, it's fluctuating a bit, so we're going to call that 35.5 psi. 35.5. We're going to go to elbow number 1. The pressure here is 32.5 psi. Now we're at T2. The pressure here is 30 psi. Here at the manometer, this is for mercury only, and you can see here that it's connected to this pipe. So if you follow the piping up here, it's connected along this pipe. So, hold on, is it supposed to be deflection?
Just not full. We haven't opened it yet.
We haven't opened it. Okay, we're gonna open it. So,
You want me to?
yeah. Thank you.
So we're gonna open these. Is the middle one closed?
Mercury manometer, and so when these are closed, Sam has opened them up, but when they're closed they sit at 0, 0, and so we're going to be reading the deflection on this side. This is the positive side, this side is the negative side, and the difference between the two is the deflection. So I'm going to take those readings. Okay, so the first one is sitting at about 2.3 inches, because we're going to read right where the silver line is. And the second one is sitting at 2 point. Okay, so the second one is sitting at negative 2 point. Negative 2.2. Take the pressure at elbow 2. And it's 26.5 psi. We're going to take the pressure at T3. 23 psi. And this is, T3. So this is elbow 3, and the pressure is 20 psi. This is the downstream pressure gauge. It's really loud here, but the pressure is 17 psi. Oh, and that's it. Okay, and so now we're at the glycerin manometer, and glycerin is a lighter fluid than mercury, so the deflection is going to be very high. This is not open yet, but this is the glycerin manometer. And because it's a lighter fluid, the deflection will be very spread out. And so we are going to wait until the mercury deflection is below 1.4 to start taking these. So we're not going to take a reading here because the deflection will be too great to measure. Ready? All right, everyone, we're at trial 2. So we're going to decrease the pump capacity by 3%. 2, 3. So now we're at 87% capacity. You can already hear a little bit that it's quieted down just a tiny bit in the lab. We're just going to wait a second on this just to make sure that it's about stable. We're going to be reading the velocity. Once the velocity stabilizes, we can start taking measurements for the at all the pressure gauges and manometers around the lab. So we'll call the velocity about 13.45 feet per second. And we're going to be doing this trial and subsequent trials a little bit differently. I'm going to be measuring the flow and the mercury manometer, and then we're going to have Sam and Bruce Bay running around taking the pressures. There we go. And then we're all going to convene at the end and give you all the values. So I'm not going to be running around for each pressure gauge because that would be redundant. So. Alright, cut. Okay, so trial 2, we're at the mercury manometer and we're going to read the deflections. So for the left positive one, we're at about 2.15 inches. In the negative one, we're at about 2.2 inches. So we're going to record that here and then we're going to get all the pressure readings from Bruce and Sam.
Upstream, we were 37 psi. At T1, we were 33. At elbow 1, we were 30.25. At T2, we were 27 and a half. At elbow 2, we were 24 and 3/4. At T3, we were 22 and a quarter. At elbow 3, we were 18.75. And at the downstream, we were 16 and a half.
That's all PSI.
Thank you.
Alright everyone, trial 3, we're going to bring this down 3 more percentage points. 3. You can hear everything in the lab gets just a teeny bit quieter again. We're going to let the velocity decrease. Just going to get a close up of that. Okay, it's about stabilized. We'll call that 13 feet per second. Alright, so the velocity stabilized, so Bruce and Sam are going to go collect some of the measurements and we're going to come over here and do the mercury manometer. So, for the left positive one, we have about 2.05 inches, and for the right negative one, we have about negative 2.50. Negative 2.05 inches. Yes, works. So this deflection is still too great to be measuring the deflection of the glycerin.
We're 34.25 for the upstream, 30.25 for T1, 27 and a half psi for elbow 1, 25 and 3/4 for T2, 22.75 for elbow 2, 20.25 for T3, 17.0 for elbow 3, and 15 for the downstream, all of those being in PSI.
Alright my friends, we're at trial 4, so we're going to bring this down 3%. And now we're going to wait till the velocity reading stabilizes a little bit. Okay, so we're going to say the velocity is about 12.67 feet per second. And we're going to come over and do the mercury manometer reading. And the deflection has decreased, so that's good. We're about 1.95 on the positive side. Negative 1.95 on the negative side. Still way too much deflection to measure the deflection with the glycerin manometer.
30.75 for the upstream, 27 and a half for T1, 25 for elbow 1, 23 and a quarter for T2, 20.75 for elbow 2, 16 and a half for, 18 and a quarter for T3, 16 and a half for elbow 3, and 13 and a half for downstream, all of those measurements being in PSI.
Alright everyone, we're at trial 5. We're going to bring this down 3 points. gonna wait for the velocity to stabilize. Okay, so our velocity is about 12 it's not totally stabilized yet. We'll call it 12.18 feet per second. So now we're gonna go to the mercury manometer. And we're gonna call the positive one about 1.8 inches and the negative one negative 1.85 inches.
Our pressure readings were 28 psi at the upstream, 25 1/4 at T1, 22 1/4 at elbow 1. We were 21 1/4 at T2, 18 1/4 at elbow 2, 16 1/2 at T3, 14 at elbow 3, and 12.25 psi downstream. All the measurements being in psi.
Alright, we're at trial 6, so we're going to bring it down 3 to 75%. We're going to wait till the velocity stabilizes. You can hear in the lab that things are quieter. So I think we can call the velocity about 11.6 feet per second. So we'll make our way over to the mercury manometer. And our deflection here is about 1.7 on the positive side. And 0.6. Negative 1.7 on the negative side.
So our pressure reading for trial 6 were 25 1/4 psi for the upstream, 22 1/2 for T1, 20 1/2 for elbow 1, 19 for T2, 16 1/2 for elbow 2, 15 for T3, 12 for elbow 3, and 10 1/2 psi for the downstream. All of these pressures are in psi.
Alright everyone, we're at trial 7, so we're going to bring this down to 72% and wait for the velocity to stabilize. Yeah, I guess we can call that 11.12 feet per second for the velocity for this trial. So, back to the mercury manometer. We are at 1.55 inches on the right side, and on the left, I'm sorry, that's on the left side. On the right side, we're at negative 1.5 inches.
Readings at the upstream, we measured 23 psi. At elbow 1, T1, we measured 20.5. At elbow 1, we measured 18.5. At T2, we measured 17.0. At elbow 2, we measured 14.5. At T3, we measured 13.25. At elbow 3, we measured 12.5. And at the downstream, we measured 9.25 psi. All of these pressures are in psi.
Trial 8, everyone. We're gonna bring this down. 3. Keep going. There we go. We're at 69% capacity of the pump. And we're going to let the velocity stabilize. Okay, we'll call the velocity 10.53 feet per second. So now, oops.
Oh, you okay?
10.53 feet per second. So now we'll go to the mercury manometer, and we are at 1.5 on the positive side and 1.6 inches on the negative side. So, for the mercury manometer deflection, we have 1.45 on the positive side, and we have 1.45 on the negative side, and that's in inches.
So our pressures throughout the system were 20.5 psi at the upstream gauge, 18.25 psi at T1, 16.25 at elbow 1, 15 at T2, 13.25 at elbow 2, 11.5 at T3, 9.25 at elbow 3, and 8.25 at the downstream pressure gauge. All of these here are in psi.
Alright friends, we're at trial 9. We brought this down to 66% pump capacity. And we're going to let the velocity stabilize. Okay, we can call that 10.03 feet per second. And here we have 1.4 inches on the positive side and negative 1.3 inches on the right side.
Pressure readings were 18.25 psi at the upstream, 16 psi at T1, 14.25 at elbow 1, 13.25 at T2, 11.25 at elbow 2, 9.75 at T3, 8.0 at elbow 3, and 6.75 psi at the downstream. All these pressures here are in psi.
Now we're doing the glycerin manometer deflection. The deflection in the mercury manometer is small enough now that we are able to do this. So we read it the exact same way, both in inches. So on the left side, positive side, we have about 2.8 inches. And then on the negative, or the right side, we have a negative 2.8 inch reading. So we're at trial 10. This is really shocking, but we're gonna bring this down 3 percentage points. So we're at 63% now. And we're gonna let the velocity stabilize. No freaking way. We're gonna call that 9.51 feet per second for trial 10. So we're gonna go over to the mercury manometer. And on the positive side, we have 1.3 inches. And on the negative side, we have exactly negative 1.3 inches. So I'm going to record that, and we'll go over to the glycerin manometer. The glycerin manometer, and I need to jump up here to see it. So we're at 2.5 inches on the positive side, and we're at negative 2.5 inches on the negative side.
Alright, some of the pressures for trial 10. At the upstream, we had 15.75 psi. At T1, we had 14 psi. At elbow 1, we had 12.5. At T2, we had 11.25. At elbow 3, we had 9.75. At T3, we had 8.5. At elbow 3, we had 6.75. And at the downstream gauge, we had 5.5 psi. All of these pressures here are in psi.
All right, everyone, we're at the last trial. If you're still watching this, extra points, but I'm also sorry for you. We're gonna bring this down 3 more points, and we're at 60% capacity. We are going to let the velocity stabilize. Okay, we'll call that 8.99 feet per second. So, we're at the mercury manometer, and the positive direction is 1.2 inches, and the negative direction is negative 1.1 inches. So we'll record that and go over to the glycerin manometer. Okay, we're at the glycerin manometer, and for our final reading, we have positive 2.2 inches and negative 2.2 inches. End of part 1.
Our pressure readings for trial 11 were 13.5 psi. For the upstream, 12 for elbow 1, for T1, 10.5 for elbow 1, 9.75 for T2, 8.25 for elbow 2, 7 for T3, and 5.5 for elbow 3. And at the downstream pressure gauge, we were at 4.5 psi. All of these readings here are in psi.
Very nice. Alright everyone, welcome to part 2 of lab 6. So we're going to be doing measurements with the hydraulic jump in the Froude number today. So the Froude number is a ratio between the kinematic forces divided by the gravitational forces. So the equation is here. It's the velocity of the water divided by the square root of gravity times the depth of the flow. And the Froude number is really important in fluid mechanics because when it's less than 1, the Froude number is less than 1, it is subcritical flow. When Froude number is greater than 1, it's supercritical flow. And when it about equals 1, it is critical flow. So you'll be calculating that in the lab, and then you're also going to be calculating the hydraulic jump and the hydraulic jump loss. So the equations for each are here, and you're going to be using this equation, the hydraulic jump loss divided by the hydraulic jump, in your data analysis. It's part 4 of data analysis. And this height, y2, is the height after the jump, and this is the height before the jump, so y2 will be larger than y1. We're going to be using, we're going to be, I guess, talking about EGL and HGL as well. HGL will be is the water height because it's open channel flow, and EGL is going to start out at a constant level, and once it hits a hydraulic jump, it's going to decrease due to losses. And the HGL does the opposite. It starts out at a level and then it increases at the level of the hydraulic jump. So they have an inverse relationship to each other. And you can kind of see that here. This is, this is EGL, and then HGL kind of comes up, and then it would come up like this. So there's not a line drawn there, but you can just follow my finger. So we're going to be looking at the EGL in this lab, and the EGL is the difference in EGL is the difference between the pitot heights. And they're going to be changing throughout the trials because the EGL changes as the water moves. And so the difference between the EGL, so the difference between the two heights that you're going to measure, should be equal to this value here. y2 minus y1 cubed over 4y1 y2. So during the lab, we're going to be looking at the actual hydraulic jump itself. And so on the last page of your lab, you can see a description of what different hydraulic jumps look like. And the fluids TAs are going to make our best guess at which category we think the jump falls under. So we're going to be announcing that as we do each trial. So, what we're going to do here, we're going to turn on the pumps, and water is going to come up in this thing, and we're going to change the head gate level for each trial. So for the first trial, it's going to be super low, and the tailgate is going to be pretty high, and so it's going to create the largest hydraulic jump. And as the trial proceeds, the jump will come up here, and then it'll start moving back this way. And Sam is going to tell us when everyone should take a measurement. And so I'm going to be here on the pitot tubes measuring where they are in relation to each other. Rusbus is going to be measuring the jump of the actual hydraulic jump, so he's going to be measuring y2. And Carmel is going to be over here measuring y1 before the hydraulic jump. And that's it.
Trial 1.
Great.
So this is trial number 1. Now.
Upstream is 0.2 inches.
So I'm just gonna
One sec. What was your downstream height, Rusbek?
Mine was 3.8 inches.
3.8 inches for downstream.
Alright, and pitot?
And then the downstream pitot tube was 3 inches, and the upstream pitot tube was 13.2 inches.
Sweet. And we're calling that a steady jump?
Yep, steady jump.
Yep, steady jump. Yep.
little bit.
Trial 2, lowering the tailgate.
We're gonna raise the head gate a little bit. This one's a little slow. It's probably good there.
Very nice.
So, and now we move on to trial 2.
Yeah.
Oh, damn it. Wrong switch. And we're live.
So now for trial 2 with the measurements.
Alrighty. And we are live. Now.
So upstream height was about 1.75 inches.
1.75.
Yep. Oh no, 0.75 inches, my bad. 0.75 inches, I'm sorry. Upstream height, 0.75 inches.
Downstream height was around 5 inches.
Downstream height of 5 inches.
And then the downstream pitot tube was about 4.5 inches, and the upstream was about 20.9 inches.
Teamwork makes the dream work. And we,
We said it was an oscillating jump.
yep, oscillating jump. Okay, lowering the tailgate for the next trial. Yeah.
I'm gonna raise the head gate a little bit. Probably good there. And we'll do our little test run right now. So this is trial 3. All right, so trial number 3.
was about 0.8 inches.
Downstream height was 4 inches.
4 inches downstream.
4, yeah.
And the downstream pitot tube was 4.5 inches again. And the upstream tube, do you mind if I just move this a little bit? It was about 15 inches.
And since the downstream was fluctuating, it's oscillating.
Oscillating.
Alright, we're gonna adjust the tailgate again for trial 4. And we're gonna adjust the tailgate, head gate. And that's about good there. We're gonna do a little test run for trial number 4. So now we're going to get the data for trial number 4. We're live.
Upstream water depth was about 1.9 inches, 0.9 inches. I'm sorry, I keep doing that.
Downstream was 4 inches.
4 inches downstream. Awesome.
And the downstream pitot tube was 4.75 inches, and the upstream is 11.5 inches.
Got it.
And the hydraulic jump for trial 4 was an oscillating jump.
Since hydraulic jump was already very close to the end, we're not going to adjust the tailgate, and we're just going to raise the head gate a little bit. Alrighty. And now we're going to do a quick run through of trial 5 so we can get our setup with the. Alright, now we're going to do a quick run through of trial number 5.
for trial 5. 1 inch upstream depth.
Downstream depth is 5 inches.
5 inches downstream depth.
And the downstream pitot tube is 5 inches, and the upstream is 9 inches.
Running a weak hydraulic jump occurrence. We're going to mark it as weak